Alrighty, 4.3, lesson 3 in our compound inequalities. Now, our previous two lessons had to deal with ands. And if you remember that sometimes the ands didn't behave the way we wanted them to. Well, ands were separated by the word and or by less than signs of some kind. And they were supposed to go together. When they misbehaved, they went separated positions, and these were considered a no solution for our ands. However, today, compound inequalities with the word or separating them want them to go away from each other because their solutions is either one thing or the other. So, or solutions should go in opposite directions, should go in opposite directions. Tomorrow, or the next lesson, will be our special cases of ors. But for the normal ors, our normal ors, they are supposed to go away from each other. And here we go. It looks like this. They are separated seriously by the word or. That means you are expecting them to go in opposite directions. How to solve? Well, one at a time, just like we would the ands. So our first one, we want to subtract 3 on both sides. And that gives us negative 10b is less than or equal to negative 40. Divide by a negative 10. Divide by a negative 10. Remember, when you divide by a negative number, you change the direction of the inequality. Negative 10 divided by negative 10 is just 1b. Negative 40 divided by negative 10 is a positive 4. Second inequality. This time we're going to add 2 to both sides. And that gives us 3b is less than or equal to a negative 15. Divide by 3 on both sides. And we have b is less than or equal to negative 15 divided by 3 is a negative 5. So we've got our two inequalities. We've got b is greater than 4 and b is less than or equal to negative 5. So our two most important numbers on our number line is going to be a positive 4 and a negative 5, and 0 somewhere in the middle. B is greater than or equal to 4. That means a solid dot for the equal to, and greater than means it's going up here towards 5 and 6. That's where the numbers are getting greater than. The second one, B is less than or equal to negative 5, also has a solid dot because of the equal to, but this one is less than, so it's going towards negative 6 and negative 7. Notice they are separate. They're going in opposite directions, so this is a usual and normal kind of or. So we've had success. Okay, a couple more examples here. Whoops, let me get it a little bit smaller so we can solve them. All right, this one we've already done in the example just above us. So we'll go to number 2. You can redo number 1 if you'd like. All right, so they're separated by the word or. We know we have an or. So the first one, we're going to add 5 to both sides of our inequality. That leaves us with 7b is greater than or equal to 37 plus 5 is a 42. And we divide both sides by 7, divide both sides by 7, and we have b is greater than or equal to 6. The second inequality, we've got a negative 2 here, so we'll add 2 to both sides. That goes away, and we have negative 3b is greater than. Negative 2 plus 2 is a 0. So we'll divide by negative 3. We'll divide by negative 3. Remember, when we divide by a negative number, it changes the direction of the inequality. And then 0 divided by a negative 3 is 0. So those are the two that we will graph. B is greater than or equal to 6, and B is less than 0. So our most important points are 0 and 6. V is greater than or equal to, so that means we have a solid dot because it's equal to, and the numbers are getting greater. towards the 7 and the 8 and the 9. The second one, v is less than 0. Since it is only less than, it has no filled in dot, and less than means it's going towards the negative numbers, -1, -2, -3. And they are separate. They're going opposite directions. So this is a normal kind of an OR, normal OR. So that's great. Okay, 2 more quick examples. Make it a little larger. So we've got our 2 problems. Let's see. So we'll add 6 on our first one. That goes away. -36 plus 6 is a -30 is greater than. And we're left with 3p because the 6's went away. Divide both sides by 3. And we have -30 divided by 3 is a -10 is greater than p. Once again, we want to write it where the p is in front. And the pointy part's towards the p, so it still has to be towards the p. And that's the one that we're going to graph eventually. Second one, let's see, we've got p's on both sides, so let's get p's on the left-hand side by subtracting p's, the 4p on both sides. 6 minus 4p leaves us with 2p's is greater than or equal to 8. Divide by 2 on both sides. And we have p is greater than or equal to 8 divided by 2 is a 4. So on this one, our 2 most important points are -10 and +4 and 0 somewhere in the middle. P is less than -10, so less than is just an open dot and going towards the more negative numbers like -11. P is greater than or equal to 4. The equal to part says it's a filled in dot, and greater than means it's going towards the larger numbers like 5 and 6. And this is a normal one. They are separated. They are going opposite directions. So we did a great job. All right, here's another one. Separate the 2 inequalities. First one's very simple. It's x plus 6. So the opposite of adding 6 is to subtract 6 on both sides. And we have x is less than or equal to 11 minus 6 is 5. Second one isn't too much harder. We have -3x plus 9, so we'll subtract 9 on both sides. And we're left with -3x is greater than -12 minus 9 more is a -21. Divide both sides by -3. Once again, when we divide by a negative number, we have to change the direction of the inequality. Negative divided by negative is a positive, and 3 goes into 21 7 times. So we're ready to graph. The most important numbers are 5 and 7. 5 and 7. They're pretty close together. So we've got 5, 6, and 7. P is less than or equal to 5. So less than or equal to means a solid dot. Less than means it's going over here towards 0. That's getting smaller. X is greater, or nope, X is less than 7 is open dot, but it's going towards the same direction. So that is not normal. That is not normal. So this one, what do you think that would be? Is it an OR? No, so this one's a no solution. This is a special case that we'll talk about tomorrow. All right, perfect. Quickly do 2 more. And we've got separated. X plus 1 is less than or equal to -3, so we just subtract 1 on both sides. And we have x is less than or equal to -4. Second one, we need to have -4x is less than -8. Divide by -4, divide by -4. That flips the inequality sign, so we have x is greater than -8 divided by -4 is a +2. So our most important numbers are -4 and a +2, and then 0 somewhere in the middle. X is less than or equal to -4 is a solid dot on -4. Less than is going towards the more negative numbers. X is greater than 2 is an open dot at 2 and going towards the positive numbers. This is a normal OR. Yay for us. Last example. We need to, let's see, that 6 is getting in my way. So it's plus 9, so we will subtract 9 on both sides. And we'll have 2b is less than, 7 minus 9 is a negative 2. Divide by 2 on both sides, and we have b is less than, negative 2 divided by 2 is a negative 1. Second one, let's see, 7 minus 5b, so we need to get rid of the 7, so we'll subtract 7 on both sides. And we have negative 5b, don't forget your sign, it was a negative 5b, is less than negative 8 minus 7 more is a negative 15. We'll divide both sides by negative 5, and once again, remember, when we're dividing by a negative number, flip the inequality sign. And we have b is greater than, a negative divided by a negative is a positive, and 15 divided by 5 is 3. So we have b is less than negative 1, and b is greater than 3. So negative 1 is important, and 3 is important, and 0 is somewhere in the middle. B is less than 1, negative 1, so open dot, and less than is going towards the more negative numbers. B is greater than 3, and open dot, because it's not equal to, and going towards the more positive numbers. Yes, they are separating. They are normal. This is the way they're supposed to look. And we're done. Have good luck on 4.3.